Now let's consider, say, the lithium atom. It has 3 electrons. And so, say we start with the lowest energy state, n equal 1. So that would be a 1s. I'll just draw a line, and I'll draw arrows to represent the electrons. So we got that from helium, the 2 electrons. That's allowed. So where does the 3rd electron go? Well, if I try to put it in the 1s orbital, then all 4 quantum numbers of 2 of those electrons are going to be the same. So I can't put them in the 1s orbital. I'll have to go to the next orbital. I have to go to n equal 2. So I have 2s, or I have a 2p. Now there are 3 2p orbitals, 3 separate ones for m sub l values -1, 0, and 1. So I could put the 3rd electron, say, in the 2s orbital. It could be pointed up or down, either way. Now, look at beryllium atom. There are 4 electrons. I have a 1s orbital. I have 2s orbital and the 2p orbitals. And so, starting with the lowest energy first, I'll put 2 electrons in the 1s level, and then I have 2 more electrons, so I could put 1 in the 2s, I could put 1 in the 2p, but the lowest energy found by nature is when I put a 2nd electron in the 2s level. Electrons like to be paired many times, and so the beryllium atom would have a pair of electrons in the 1s level and a pair in the 2s. Can't always predict it, but we can do experiments and then see the trends and what nature picks what is most stable. Okay, now we go to the boron atom with 5 electrons. So we have our 1s, our 2s, and our 2p. And so our first 2 electrons go in the 1s, the next 2 electrons go in the 2s. Now we have our 5th electron. The only place for it to go is in one of the 2p orbitals. It can go in either one. Now nature is going to pick exactly which orbital it wants it to go, either the -1, 0, 1. So there are a variety of ways, but those energies are only separated by a small amount. For purposes, doesn't matter which one we stick it in. Now we can have a shorthand way of writing these diagrams. So what we'll do is we'll use a superscript for the number of electrons. That's the number of electrons in an orbital. So in this case we would have 2 electrons in the 1s orbital. So it would be a way of representing this diagram. Say we had this shorthand notation would be a way of representing this diagram. If we have 1s2, 2s2, that would be a way of representing 2 electrons in a 1s orbital and 2 in a 2s orbital. For our boron atom, we would have this shorthand notation for that diagram. The shorthand notation of writing what are called electron configurations of the atoms. Electrons configurations are important because they dictate the physical properties and chemical properties of the elements.